All right. I see someone in chat. Oh, hey, Mike. Hi there. All right. I will share a screen and get started. All right. Here we go. Welcome to the grab bag session of the Minnesota GIS LIS conference. I am Nancy Reed. Okay, and let's see. We need to pause for, okay. All right, I'll keep going and we'll get started. All right, so taking the enterprise to QGIS, and I am Nancy Reed. I'm from the Metropolitan Mosquito Control District. I have listed the rest of my leadership team here as co-authors because this has been a joint process. So introducing new technology is a challenge in any organization. First, you have to make the choice of what technology you're going to, and then you have to make the change and get everyone to come along with you. They will ask, how will we do the things we've always done, and what can we do better with this new technology? So I'll be talking today about how we did that with desktop mapping at MMCD. So the Metropolitan Mosquito Control District is a 7-county metro agency. We're supported by property taxes. We treat wet areas with biological control materials to control mosquito larvae. We try to focus on the larval stage because we have nice biological controls we can use to prevent adults from coming out and attacking our citizens. We do some adult control if needed. Mapping is an essential part of our work. We have to find the larval habitats, which include all sorts of wet areas from larger wetlands to very small stormwater structures, street catch basins. And we also map adult habitat, wooded areas where we do surveillance. And of course, we need reference. Aerial photos are essential for us finding our way around, as well as streets and landmarks. We also use this mapping system to track all of our actions. Each of our wetlands has a unique number, and we can record our inspections and treatments. We've also started to include mobile mapping in our web application, but we still use paper maps for reference for many things. So a little bit more about our total ecosystem. Desktop mapping has been our mainstay for years. It's flexible. Our field staff use that to update wetlands and wooded area boundaries from many sources. They'll create their paper maps with that. And then we have 6 different field offices. So all of those individual files are then pooled for the whole district. And we push that up to our enterprise PostgreSQL database and our web application, which then gets that down. We call it Webster. It's developed by Houston Engineering. That gets it out where all staff can see a common picture, and our 220 field staff can see that on their phones and have access to that. In some cases, we've started doing web mapping through the web application itself. We have catch basins working that way. Our front desk can enter information from citizen calls if they want us to do or not do something in a particular area. And we push that back through the cloud database. And then that goes back to the desktops. Again, that they can use that in their paper maps. But one of the big things that people are using desktop mapping for is actually a way to run queries and stats. It's been kind of the front door to our data for our field staff for many years. So as I said, these field maps are all managed by the field staff themselves. They started using MapInfo in 1995. It was a user-friendly desktop mapping system, and it was actually the earliest desktop GIS to show an aerial photo background before the old ArcView was able to do that. MapInfo was. So that's how we got started with it. By 2003, we had completed digitizing all of our old hand-drawn maps, and we're using desktop mapping entirely. And that served us well for over 25 years. But, you know, software environments change. With Windows 10 and with new server versions, we had upgraded MapInfo a few times, but it just became a question of, is this really the best path to upgrade again? We looked at how MapInfo itself was changing and what training we would need. MapInfo stores files in a proprietary format called tab format. It gets pretty expensive for the 40 licenses for our full-time field staff that are using this, to say nothing of we'd like to have some additional licenses for seasonal staff to use. And we've also found that there's really a small number of other users in our area and in our field. We were having trouble finding support. So we looked at switching to ArcGIS. Of course, that would take a lot of training. It would be as expensive as upgrading MapInfo. And it will read MapInfo tab files, but it doesn't edit them as far as I can tell. So that, you know, there were some kind of issues there. Of course, there are lots of other users in our area and field, and so it would be easy to find support. But we were making this decision in August of 2020. As some of you might recall, there was a lot of unknowns regarding revenue shortfalls from tax collection at that point. So we were pretty price sensitive. We were also looking for something that was easy to install on home PCs if we could. And so we started looking at another option, QGIS. It's the most widely used open source GIS. It's professional grade, worldwide developer base. It can read and write MapInfo files and works very well with our enterprise PostgreSQL database. It's low cost, free to download, no license fee, no annual maintenance fee. As an open source project, I don't want to say it's totally free because open source works because people do contribute at some point, but there was a lot more flexibility in the payments. And we know we need to spend time on training on something, but there are lots of resources available for training on QGIS. We also were happy to find some other users in Minnesota. We appreciate that USpatial was teaching some QGIS as an option for their GIS 101 classes. And the DNR had been using QGIS in some areas. So we didn't feel like we were going to be a total island. And we appreciate that the GIS LIS Consortium has done previous workshops on QGIS. So that's been very helpful. And we had some pioneer users that tested it and showed that we could do the essential things that we needed to do. So based on comparing all of these criteria, we decided to go with QGIS. So that was making the choice. Now making the change. Well, our plan was to use the winter to learn ways to do MMCD tasks in QGIS. We don't do much field work in the winter, so that's our biggest time for sitting at the computer and working on maps. Our goal was to have everyone be able to do basic tasks in QGIS in time for the 2021 season, which for us essentially starts April 1st. although it was helpful to know that because QGIS could read and write map info files, we could use both systems during the transition. So how do we get there? How do we get everybody there? We started with why, explaining the choice. We had to show that it can be done and show our results from our map pioneers. We had to set up the environment and then provide lots of training in lots of formats. And really what we found is helpful is task-oriented training that people can relate to. And then listening to issues from users. Now, part of the challenge was that those of us leading this change were also learning pretty much at the same time. So we tried to establish a very cooperative environment where we were sharing information. So one of the first things we did was the Maps notebook. This is a Microsoft OneNote notebook. It's a great way to share resources. You can have multiple authors. You can have all sorts of different kinds of things that you can put in the notebook. People can see the pages. I don't know if you can see my pointer here. Anyways, but we had pages for common MMCD tasks. So when people were looking for help on something, they could find it easily. There were links to videos and guides and videos by our own staff. And we kept adding material to this. One of the biggest things we did was online videos. So there are a lot of training videos out there for QGIS, and particularly those of us that were being map pioneers really dug in with the available training to learn the general use and which tools were going to be most helpful for us. And then Casey Herrmann, one of our leadership group, just did a wonderful job of making a bunch of custom videos that were really focused on specific tasks. So each of these videos was, maybe 10 minutes long. So they're short, they're focused, and they really helped people see, okay, well, this is the kind of thing I do every day. How do I do it in Q? We also did webinars where those of us that had been working on different aspects of Q and how it fits in our tasks would pick a topic and dig into that in more depth and then share our results with other folks. And we recorded these and made them available on the Maps notebook as well. Now, some of the things that we had to deal with right away was the question of installation and setup. Well, which version of Q? QGIS is always undergoing active development. There's frequent updates, but they do have a thing called long-term release, which is a fairly stable version. So we tried to make sure that everybody was on, well, our IT staff got everybody on the most recent long-term release, so that as we were developing videos for each other, we at least had that as a base. We're looking forward to going to the next long-term release version soon. And certainly people that wanted to explore other things could go with more advanced versions. Then the next thing was all those little basic setup things that you, when you've been working with a piece of software for a long time, you kind of forget that all the things that you did at the beginning. Things like setting the default coordinate reference system for projects and layers. And we actually had problems with some old map info tab files that were so old that the projection info wasn't read correctly. And so we had to do some fixes on that, but got that worked out. And then we started by trying to help people learn the new language, projects versus workspaces, layers versus tables, all of that kind of thing, so that people could start feeling comfortable with even the QGIS training. Projects were great. So that was one of our first introductions, was getting people to know how to work with projects, how to view the different panels that are available, looking at settings and options. Again, just getting comfortable with their work area. And then opening air photo layers. I mean, you can certainly do that in a project, but since that's probably not the easiest thing for people to start with, and we wanted people to get started right away. So I pre-made some projects with the aerial photos that people would need. These are all WMS services. And then we can also use layer definition files to make those easily accessible for people. We were able to put some of our drone photos in and show people how to access those drone photos in QGIS. And then, of course, editing layers, the basics. People knew how to do this in MapInfo. They just needed to know, okay, where are the tools in Q? How do I do this? What does it look like? So layouts and printing maps. This part had some differences from MapInfo. And again, that's a big task that a lot of our people are doing, printing maps and the reference cards that go with them. We developed templates and showed how easy it is to share these template files and setting scale for that. That was actually pretty easy to do in Q. And something beyond what we had been doing in MapInfo, one of our map pioneers found ways to automate printing a map series. So most of our maps are based on square mile sections. So if you think about the public land survey sections here, so he would set up an area of sections and use that as the guide map, and then set up a template that had two kinds of layouts, one with the photo and one without. We call that the cartoon map. It's a little easier to see what's going on sometimes. And then he could just run a whole series of sections on this and have it automate the process and put it out as a PDF. So that was a great tool for just getting a lot of maps out in a hurry. Labeling, oh gosh. Yes, we can make labels, and there's a lot of ways to control labels in Q, and some of it is rather different from MapInfo, and we continue to work on all the nuances of label positioning. Our field staff tend to take pride in their maps, and they like them to look good. So we did find things like you can toggle the display of unplaced labels. So all the collision rules, all that sort of thing on labels we've been working with. There's also something called auxiliary storage in Q that helps when you're managing custom label moves and keeping those label moves associated with the objects in question. And then another challenge was landmarks. Our folks had developed their own landmark layers with often they had just been putting symbols on the map with no attributes. So bringing that over into Q, if there's no attribute to govern the icon that you're associating with it, it lost those icon associations. So that's been a manual fix for a lot of things. Plus, in MapInfo, you can store points, lines, and polygons in one table. In Q, that's getting split up into separate points, lines, and polygons. So that landmarks has been an area that people had to rework quite a bit. But people started to get creative and play with all the things that they could do in Q, like find cute little bee symbols and learning how to control the size and zoom level of that and make it all work. So that's been going okay. Now, the really powerful stuff, some of the really powerful stuff is getting into filters and queries. Again, people have been using desktop mapping to do a lot of work with their data, so they were really concerned about this. So there's several ways to do this work in Q. This is a basic filter. In this case, if we wanted to see just the sites that are treated on foot and eliminate the sites that are treated by helicopter, this was a filter for that, example of that, and people can run summary statistics on what they're filtering on. There's also an expression builder that's more powerful. You've got pretty much full SQL style language available. You can do joins, you can do group bys, you can do summary statistics. And we ended up using that for one of our most frequent tasks, which is taking the inspection and the lab identification information that's in our database and using that to select the sites that then are stored as a shapefile and given to the helicopter so that the helicopter pilots can see where they're working and see what they've done. So that process, we had to download a CSV, open that in Q, join it with the geometry, people adjust the site shape if needed, and then save that whole thing as a shapefile for the AgNav guidance system in helicopters. And the good news was that people, once they got this figured out, this actually took less steps than it did in MapInfo because it was easier to save the shapefiles in Q. With the expression builder, we can also start doing graded maps. Like this is the count of air sites per section, categorically. There's, all of that kind of tools is available. There's also lots of fun plugins. This is a group stats plugin that actually works like pivot tables in Excel. If you've ever used that, you can just drag the different things like if we wanted to, in this case, how many sites designated as pre-hatch treatment are there by foreman in the different zones. Well, you just drag those down there and it makes this table and does all the stats very easily. It's a wonderful little tool. And then finally, we've got the database manager, which is an even more powerful way to do queries and work with layers. You can run queries on local layers, build full SQL and add that as a layer. And conveniently enough, the SQL query builder in the database manager looks a lot like the one that's in MapInfo. So some of our folks that had been doing queries in MapInfo for years could see something that looked a little more familiar. So in this case, we did a query off of this layer of breeding sites, wetland sites, and then added that as a layer in our project. But with the database manager, you can link not only to local files, but to files in the cloud. So we could access data in our PostgreSQL database. And so you could actually, because that's live on the phones, people could be entering points in the phones and you could see this showing up live in QGIS on your desktop. Yay. So did we meet our goal for 2021? Well, many staff were able to do all the needed tasks in QGIS in time for the 2021 season. So that was good. But we did have some people who just didn't feel ready to start the field season without MapInfo. Again, a lot of it was that helicopter support that they have to be able to do, just on very short notice. So we did leave the hybrid environment for the 2021 season. And we have a new goal, all Q in 2022. The remainder of the staff are shifting their tasks to QGIS as of this fall. And then we are changing our file formats to GeoPackage, the open format, similar to a geodatabase for those of you more familiar with ARC. And I just threw Marie Kondo in here. Changing the file formats to GeoPackage is also going to be a great opportunity for us to do a little house cleaning on our 25 years of collected tab files. So we'll clean house before we move into the future. So challenges that are left, converting custom programs in MapInfo for more complex mapping tasks. We've got some of those to work on, and we're going to develop some more Q-tips for this winter to keep people going. So making the change, we did a staff survey this fall just to see where people were at. And we had folks saying, it took me 5 years to learn MapInfo. It'll take that long to learn Q. And that's true, particularly since we're out in the field all summer. It's not like we do this every day, but in the winter, people really get into it. There's so many options in Q. That's one of our challenges, is just finding which things we're going to be using. And then there's more on reports and queries to learn. So in summary, QGIS has been a powerful and stable desktop mapping platform for us. And I say desktop and beyond because it can do a lot more than just your standard desktop GIS. It's been a good value for our organization, and I think it's going to be flexible for our future. And another thing that bodes well for the future is that our seasonal staff, some of them were saying, hey, with QGIS, I can learn this at home if I want to do this over the winter. So I recommend it, and we're ready for the future. With that, I'll look for any questions.
Yes, thank you, Nancy. I'm filling in as moderator suddenly. Apologies for any confusion there. If you have questions for Nancy, please go ahead and put them in the Q&A. We've got about 2 minutes before we get to Caleb. There is a question in the chat, however. Nancy, what's an approximate percentage of staff that were able to successfully make the switch in 2021?
I would say half. So we had, and some of it varied by field office. You know, we have 6 different field offices. The field office that was mostly our map pioneers, you know, they got a head start, so they did very well. Some of the other field offices, you know, it had more challenges, but we're getting everyone in for the next round.
Great, thank you. And there was the congrats from Mike in the chat as well. We are actually about 70 seconds away from needing to cut to Caleb. So, and I didn't want to cut off your talk, Nancy, because it was so good. So thank you for that and for introducing yourself. And I know I want to have some follow-up with you, but hopefully everybody knows how to reach Nancy. If you have follow-up questions, you have contact info you want to share, or maybe we all know you.
It's yeah. If you Google Mosquito Control District, anyways, I can put my address in the chat if you want. And it's on my first slide. So if the recordings do end up available, my email address is on my first slide. And I would love to talk to people about Q, and I wish we had a local QGIS support group. That'd be great.
Well, thank you so much, Nancy. A round of applause, I guess, virtually from everybody. And why don't we go ahead and Caleb, if you want to get set up, we are just seconds away from when you can start. Oh, and I apologize again, I'm substitute moderating. Our next talk, ooh, I don't even have it. Caleb, sorry, I'm winging it. It's been a rough morning. Are you able to introduce yourself?
Yes.
Okay,
Hi,
sorry
everyone.
about that. I'm going to go off.
Yeah, no worries. I'm Caleb Mackey. I'm a full stack developer at WSB. And yeah, this presentation is just going to be just on that, building a full stack application. So I will share my screen now. Okay. So, Yeah, this is like I said, this is on full stack development. So let's get started. So first off, just before I get going here, I do have a GitHub repo that has all this stuff in it. So there's a demo app in here, this presentation, and there's like a front end and back end aspect for that. So I'll leave this up for a minute if you want to go to it. Okay. So here's kind of what I want to talk about today. So I want to talk about what does full stack mean? And with that, we'll be working with the database. We'll be creating a web service, and then we'll be creating documentation for that web service with something called Swagger, and I'll explain more about that. And then we will have a front-end app that actually will talk to our backend API and consume the data. So what do we mean by full stack? So really it's just, just means there's a front end, which, could be a client-side web application, and a backend where maybe there's, some sort of web service that talks to a database or just runs server-side processes. And there's a whole lot of different frameworks, and different ways to build stuff, a lot of technology stacks, like if you're a C# guy, there's the MVC stuff, there's Java backends, there's all kinds, lots of ways to skin the cat with that. But in our case, we're going to be talking about, we'll have a Python backend with a Vue.js front-end app for the demo. So even though there's a lot of different approaches to full stack application development, there's a lot of common patterns that you'll see. So one is talking to a database. And then if you're building a REST API like we'll be doing, when you work with a database, we'll need to serialize that data to JSON so that it can work with our API. And then in the client app, you want to do something with that data. In our case, we'll be looking at it in a map. And then a cool bonus is if you can provide good documentation for the backend API, because with the REST API, it doesn't need to just be used in a web application. It can be, consumed in a native app or anything that goes over HTTP protocol. So it's nice to have that good documentation, and I'll show you how we can do that. Okay, so what we have, maybe I'll just show this really quickly. This is a brewery finder app. So essentially, it's not very full featured, but essentially we can identify a brewery and, interact with those on the map. And then each brewery can have beers associated with it. So this could be like a nice crowdsourcing way where you can, see what kind of beers are served in a certain brewery. So, Mosquito brewery, for example, this is the only one in the sample database that actually has beers. But essentially what you could do is, they all have a style. So you can search for breweries that serve like an IPA or sours or something like that. So yeah, it's a really simple app, but it's working with our backend web service that we're going to create here. Okay, so then what we'll do in the Python backend is we're going to use a library called SQLAlchemy. And this is an ORM, which makes working with the database really easy. And then to get this data serialized to JSON and also load SQLAlchemy ORM objects from JSON, we'll use this library called Marshmallow. And this provides easy object serialization and deserialization. And then this will be served up using Flask, which is a micro framework for Python. And it's a really lightweight thing that you can, you can even do web pages from this too, but we're just using it for REST API. And then there's an extension called Flask RESTX, which will create our Swagger documentation. And then there is a Flask accepts module that's kind of built on top of that, that allows us to use these Marshmallow schemas because those don't play very nicely with Flask RESTX out of the box. Okay, and then for the front end, we're going to have a Vue.js Vue.js web app. And this is created with TypeScript using the Vue CLI. And then for the UI framework for this, it is using Quasar, which is a material design framework. And then for our mapping component, we have Mapbox.gl. So I kind of said a bunch of jargon here. So I think we need to break this down. So first off, if you're not familiar with like a REST API, it's basically just a set of protocols and definitions, and usually works with JSON data. You may have heard of SOAP as well, which that is a similar thing, except it uses like XML typically. And ArcGIS has a REST API that is basically the driving force between ArcGIS Online. All the services are queried through the REST API when you're in a web app. So yeah, and they're just comprised of endpoints that do specific tasks, such as querying data, adding data, or running server-side geoprocessing services or whatever. It can be a lot of things. So then what's Swagger? I know I've mentioned this a few times. So Swagger is a set of tools that implement the Open API specification. And basically the Open API specification is just documentation for like a REST API. So it basically defines all the endpoints and like what kind of parameters you can pass in and then the data that you get out. So it makes it really nice for developers to, to see what an API can do. So I will show what that looks like real quick. So this is our API that we created. So this is what's called Swagger UI. And basically you can have different namespaces, and then you can actually define the, the endpoints associated with each namespace. So for example, if you want to get breweries as GeoJSON, we have an endpoint for that right here. And then the cool thing is it shows you all the query parameters you can pass in. And then it also will let you run the code live and shows you like what you get back from it, what the expected response is. So if we just try this out, for example, I say execute here. So the other cool thing is it shows you like the curl request that is actually made. And then, we get back a feature collection with all the brewery info. And then we can also query, by these various attributes that are in the data. So we could, say city equals Minneapolis. So if we run this, we can see first that we're running this query here where city is Minneapolis. So it's only pulling breweries that are in Minneapolis. So this is a really handy tool for developers, and it's also nice to keep track of what is available in the API. So as I mentioned earlier, we're using SQLAlchemy to talk to the database. And this is a really nice module because it doesn't really matter what the underlying database is. It could be Postgres, Microsoft SQL Server, or Oracle. And no matter what the underlying database is, it uses a common API to query things. So you don't have to know the dialect of the specific database you're working with. So it also can prevent SQL injection, which is a type of attack where someone could like maybe insert like a drop table statement in a query. You can also have ORM level triggers, which are similar to database triggers, except these only happen when you access the data through the ORM. So you can do stuff, before insert, after update, that sort of thing. You can also do eager loading, which that is like if you have a parent-child relationship, you can fetch all the children at once as you fetch the parents, rather than having to access, in a lazy loaded way where for each parent you access the children, you can just get them all at once as a join table. And then for spatial functions, there's also a GeoAlchemy package, which extends SQLAlchemy, and it has, it was mostly built for PostGIS support. So it has all those methods out of the box, but it also works with SpatialLite and SQL. But the operations there depend on what is supported by the database. So here's a very basic example of how we can set up like SQLAlchemy with database models. So essentially, we define a model, and then you set up the columns, and then we can also define relationships. So In our case, we have a one-to-many relationship with breweries and beers. So like one brewery can serve, one or more beers. So here we're defining a child relationship of beers. And another cool thing you can do is you can do cascade deletes. So like if you delete the parent brewery, it will also automatically delete all the child beers. And then we can also, in the beer child class, we can define a brewery ID, which has a foreign key relating back to the brewery ID. And then from that, we can, anytime we're in a beer object, we can always see which brewery it's associated with. And then when you're inside of a brewery object, you can always get the list of beers by just calling brewery.beers, and that calls all the children. So queries are also very simple with SQLAlchemy. Like for example, if like the query we ran, city equals Minneapolis, you can literally just do this, where you have a session, you query the table, and then you can set your filter, and then you can also do things like order by or limit. All those modifiers exist. And then to get the result, the first result, we can just call, this variable dot first, and then we can get the brewery name. And then you can see any breweries it serves by calling the dot beers operation. So then, it's really easy using this method to like find breweries that serve certain type of beer. So if you want to find like an American style, looking for beers that have a style set to American style India Pale Ale, so that's just an IPA. This is kind of a long way, just like a regular Python method. So first you can just query the IPAs, and then you can create this empty list here, and then if the brewery is not in this list, we append it, and then you can return back the sorted name. But that's not really super efficient. And if we have this nice ORM, we could let that do the work for us. So an easier way to do this is we can do a simple query. So first we query the brewery, and we can join it to the beer table, and we can filter by the child beer that's equal to India Pale Ale, and then just order by the brewery name if we want. That's optional. And that will give us the same result. Another way, we can also use an exists query. So essentially we can do it the same kind of thing where we filter by the brewery, and if the child beer has this IPA style. So these ways, it's nice to take advantage of the ORM in this case, rather than doing this kind of traditional kind of Python way to do it. Okay, so now how to deserialize. So this is where we can use Marshmallow. And then the nice thing about Marshmallow is we can specify read-only and write-only fields when we define our schemas. And the reason we want to do that is because if you have fields that are automatically created, like such as an ID that's an auto-incrementing primary key, we can set that to dump only. So then that way, whenever you query the database, you get the ID back. But if you're pushing data up there, we don't want to send an ID because that gets set up by the database, behind the scenes. So here's just a quick example of like creating a schema for like, say the beer table. So this looks pretty similar to the SQLAlchemy schema, or model, I should say. We define the field type, and then you can have like a little help if you want. But then the cool part is when you want to deserialize back. So like so each schema object has a load and dump method. So dump will serialize to JSON, then load will take JSON and convert it to something else. So what we can do is we can define a post load method that will actually create this to our beer ORM object. So basically it takes in data, which this is a dictionary or JSON of the attributes. Then we can just create a new beer from that, and it honors these dump only fields, or whatever's in the data. It just brings that in and creates a database object from that. So it's really handy. And then for our web service, we just have Flask. It's a lightweight micro framework. It's got a lot of plugins that are really nice. And we're using Flask accepts and Flask RESTx to create that Swagger documentation. And this is kind of how easily you can make a Flask app. So, this is a minimal sample. So you define a Flask instance, give it a name. And then this is like an example of one endpoint that return this JSON. So not a very cool app, but this is how easily you can set one up. And I think that is actually all I have for slides. So I'm moving this week, so I did not get to spend as much time on this as I wanted. But now I will show some of the code on how this is done in the backend. So basically with the repo, I'll actually show this in GitHub first, because I want to kind of walk through this. So what we have is kind of three main folders. So the presentation that we just saw is in this presentation folder. Our backend services are in this services folder. And then the app that we're actually running, the Flask app, is right here in this app.py. It's pretty small because we're just going to bring in a blueprint for brewery. And this is kind of modular in that we define all this brewery.
Caleb, I'm sorry to interrupt, but could you zoom in just a touch? It's a little small.
Oh, yeah, sorry. Yeah.
Thank you.
Is that better?
Yes, thank you.
Cool. So yeah, this is our Flask app. So we're just running it and we're bringing this blueprint. And then, as I mentioned, the services. So this is our actual blueprint for the brewery data. It's all set up right here. So first we define a blueprint. And this is just a Flask thing where this is like a modular piece of endpoints that we can just bring in, or, you know, it's easily portable to another app. And then we have our models. So this is where we define all of our schemas. So we have a bunch of tables, and actually I want to show, so the data for the backend is being stored in this SQLite database, which is also in this repo. And basically we have these tables right here. This one's not currently being used, but we have brewery, then we have beers, and then we have categories, which these are just categories of beer. Then we have styles. So all these fields are going to be represented in this models here. So we have our beer table, we have our brewery table, and these just correspond to the columns, style. And then to serialize and deserialize this, we have a schemas file. And this is what is using our the Marshmallow module. So, you know, we showed this already. So to get a brewery schema to dump, you know, just calling this schema. And then I also have a method to get the geometry as GeoJSON, because this database is not spatial enabled. It's not like a Postgres database. So we just have a latitude and longitude field. So I have a simple function here that converts, you know, makes a GeoJSON point for that. And then these are all the schemas. So then how do we actually use these? So in our brewery API, so this is going to correspond. We have a namespace here, which is coming from Flask RESTx, and that is going to correspond directly to this guy right here. So these are all the methods in this file. And the way this works is you define a route. So we have, first off, a base path of breweries. And then just to get all the breweries, this has, you know, the endpoint to this, since I'm not adding anything to it, it's just breweries. So then we can define using a Flask X resource subclass. I have a breweries handle here, where we can get the breweries. And I have a simple helper function here called query table, which basically takes the database table and then the session object, which that's what controls our commits and reading access to the data. And then it will pass into any of those query arguments that we might make, and then returns the data back. And the nice thing here is we're also using this accepts and responds methods, these decorators from Flask accepts. And basically we can define what it accepts. So we have I have a helper function here that basically reads all the fields from the table and adds those as parameters. So if we do that again, it basically adds all these fields as parameters, so we can query based on any of those. And then for the response, I'm calling out this brewery schema. And then if we pass in mini equals true, that means we're expecting a list. So on this one, what that looks like is this. So then the response part shows this example right here, a collection of mini brewery schemas. And then did the same thing for a GeoJSON, except it's the same exact data, except we wrap it into features. Then we take all the properties and wrap that into properties, and then the geometry as well goes into that GeoJSON format. So that is essentially how we can easily tell, what the request is expecting and what is supposed to come out. And I see we're running pretty short on time, so I'm going to try to skip over to the front end quick. So that's in a nutshell the back end. It's kind of hard to cram all this into a 25-minute session because there's a lot going on, obviously. But now if we go to the front end, so if you're not familiar with Vue.js, it is like a framework similar to like React, where it's got full TypeScript support. It's got routing, single page, for single page applications, and it's just like a framework that has kind of less of a learning curve than like something like Angular, but it's just as powerful. So basically with our Vue app, we have our main file here, which we're just bringing in, we're going to instantiate the Vue app using create app. And then we're going to bring in Quasar, and then we're using some plugins for Vue. And then we have an app where basically we define an initial template, and this is using Quasar, which has a bunch of helper components. So one of the benefits of a framework is you can build these components, they're like web components, but in this case, they're specific to Vue. And then you can reuse them all over the place, and it makes it cleaner, for your code. And then one thing we are bringing in is we're bringing in two components. We're bringing home and sidebar. So in our Brewery Finder app, our homepage is essentially just the map, and this is a Mapbox map. Then I have a sidebar as well that displays the brewery information when you click on one. And then these buttons actually don't do anything, but this is where you could set up a search, to autocomplete and find a brewery. And then this would be where we could set up a beer finder where you could look for IPAs and then see which breweries serve those. Then basically the sidebar component is made up of a few other components. So we have a sidebar, and then inside that sidebar, we have a brewery info. And that's what kind of shows our brewery information. So this just gets set to whichever, whenever we click on a new brewery, we query that service and just find out which brewery that is, and we just autofill in some stuff here. So the nice thing about these is these have templates where we have this selected feature, which is equal to a brewery. And then, we can use this kind of mustache handlebar syntax to, call out the properties, autofill, make all these elements dynamic, basically. And yeah, so then one other thing that we're doing, and if we go back here, I know I don't really have a whole lot of time left here, but just to get this stuff started. So for the Vue app, how we can run that locally, you can kind of play with the syntax and stuff. You would just cd into the Brewery Finder folder, and then we npm install the modules, and then we do npm run serve, and then that will run this locally on your port 8080. And then, yeah, just what the app looks like. So I know we kind of ran out of time here, but looks like it's time for questions. So I'll open up right now for any questions.
Well, thanks, Caleb. Yeah, we do have a couple questions that have come in. The first one is from Kitty Hurley, and she asks, does Swagger UI automatically generate API routes as they are created?
Yes. So one thing, so basically the open API spec gets stored in the swagger.json file. So here's where all of the, the properties, every endpoint is kind of set up here. And essentially the magic kind of happens. So you were asking about the data models, I think. Where those are set up is those get stored at the bottom here. There's these models. So here's where we see, a brewery load. So this is creating a new brewery. all these are kind of created automatically by using that Flask RESTx extension. That basically, the Flask RESTx kind of generates the necessary JSON structure based on what we pass in and take out. So yeah, this, and this can be used, Swagger UI can be used with any endpoint or any REST service, as long as you provide, if you don't have something that automatically builds your JSON structure like this, you could build it yourself and still use that documentation. So this isn't specific to Python or any framework in particular. It's just really based off this open API spec.
Great, thank you. We have another question in the chat in the Q&A from Mike Dolbau. What are some other methods or platforms to create a REST API from a database outside of Esri Tech or the Python tools you discussed today?
Yeah, so I know another one that's really popular. It's a .NET one called the Entity Framework. And it's essentially the same thing where, you define your models. There's a lot more boilerplate involved with that, but it works the same way. It's got an ORM that works under the hood. Another one, if you use Java, is called the Spring Framework. And that one, I know that Esri's JavaScript 8 or ArcGIS REST API is based on Java. And it's all custom. It's not Spring Framework, I don't think. But yeah, I mean, there's really tons, really any language that can create these protocols can do it. Node.js is another one where you can easily create REST APIs. So yeah, there's a lot of ways you can do it. It's definitely not, unique to Python. So yeah, there's a lot out there for that.
Great, thank you. We still have a couple minutes left. I'm going to throw out a question since I can't apparently type it in as host. You talked a little bit about Angular as well and selection of Vue, but could you elaborate a little more on maybe why you wound up using Vue rather than Angular or React or some other framework?
Sure, yeah. I guess just because it's a little more approachable than Angular. Like in Vue, you can accomplish a lot of the same stuff you could accomplish in Angular with way less code. And then you don't have to worry about like the service kind of architecture that is in Angular. And initially though, Angular had some advantages where initially when Vue came out, it didn't support TypeScript. Where now, Vue 3 is out and that was built with all TypeScript and it's very heavy TypeScript oriented now. I guess the short answer is just because it was more approachable and I could get up and running faster with less code, so.
Great, thank you. We still have about 90 seconds. If anybody has other questions, please throw them in the Q&A. Otherwise, hoping one or two more come in. I will say thank you so much, Caleb. Great talk. And thank you as well for introducing yourself. Apologies for the moderation difficulties today. Virtual conferences, yeah.
Right.
And any other questions? Well, thank you again, Caleb and Nancy as well. A couple of great talks to kick off our first virtual conference, and might I say, hopefully our last. Hope to see you all somewhere next year. But thank you both again, and thank you for everybody who made it out today to listen to these great talks, and hope to see you at the rest of the conference. So thank you.